All right, this video here is going to deal with what's known as the reciprocal function, also known as the rational function. And it's the parent function for that, which would be like the simplest function that involves a ratio. The key here with reciprocal or rational functions, the variable x does need to be in the denominator. So if you think of like the easiest fraction or ratio that you could think of, that would be like our parent function, in which case it's going to be y equals 1 over x. And that is like the easiest fraction that involves an x in the denominator. If it was x over 1, it wouldn't be a reciprocal function or a rational function. But this is our parent function, y equals 1 over x. It's kind of tricky to think about graphing it, so we're going to just make an x and y table for this one. I'm going to plug in some points for it, and this one's going to be probably the most intensive process, but it's really not bad. Just plug in values of x and see what they spit out. Notice how I can't plug in 0. I can't divide by 0. That's something called undefined. So I'm not going to even be able to plug in 0 into my x values. It's not what's called it's not in the domain of the function. But I could plug in 1, right? So if I plug in 1 for x, 1 divided by 1 gives me 1. So I'm going to plot that point. I can plug in 2 for x, right? 1 divided by 2 is 1 half, right? It's 0.5 or 1 half. So if I plug in 2, I'm going to get 1 half. And I can plug in 3 and get 1/3, 4 and 1/4. It's going to kind of keep getting smaller here. What I'm going to do now is actually going to plug in 1 half for x, right? And what this is going to do is give me a different part of the graph, kind of, right? So 1 divided by 1 half is the same thing as 1 times. Dividing by a fraction is the same thing as multiplying by the reciprocal. So instead of dividing by 1 half, it's actually multiplying by 2 over 1. And that's going to give me 2, right? So if I plugged in 1 half for x, the whole thing is going to equal 2. So 1 half comma 2. And then I could plug in 1/3 and get 3, 1/4 and get 4, and all these things. But basically, I have a general idea that the shape is going to continue in this pattern all the way to the right. But notice how I couldn't plug in 0, so I'm still to the right of the graph. I don't have anything over here yet. So on my graph, I'm going to continue my table. Now I'm going to just plug in negative values. So if I do negative 1, 1 divided by negative 1, well, it's the same thing as 1 divided by positive 1, except for it's negative 1. So it gives me negative 1. I could do the same number here, but make it negative. So instead of 2, I'll plug in negative 2. So 1 divided by negative 2 is just negative 1 half. And so negative 2 I plugged in, and I got negative 1 half. And I'm going to plug in negative 1 half the same way I plugged in positive 1 half here. Instead of getting positive 2, if I plug in negative 1 half, I'm just going to get negative 2. And so now negative 1 half, negative 2 is right there. And I kind of get the same shape, except for it's going downwards. But it's more or less the same. It's just that my y values are now in the negatives because I plugged in negative numbers. And so this right here is your reciprocal function, like the parent function of a reciprocal or irrational function. It's the easiest one you can get. Again, it did require a little bit of work, but you want to get comfortable knowing that one.